Swayam Prabha. Digital India. Educated India.
We are going to continue our discussions on the rotation, kinematics of rotation, and in this lecture I am going to talk about a few mathematical preliminaries that will be required to understand our further developments, and I am going to discuss the situation of rotation of a vector about an axis. How does the vector transform when it is rotated? I mean, when you do a rotation about an axis, an arbitrary axis. We have been finding out rotation matrices corresponding to rotation about the individual frame axis, but suppose we have an arbitrary axis which is not one of the frame axis. If we have an arbitrary vector, unit vector given, and I want to give a rotation about that axis or that unit vector, how will I find out that rotation matrix? Therefore, rotation of a vector about an axis will tell us that. First, I will develop the dot and cross product, the standard vector products, as matrix products. These are quite standard and are well known. Suppose you have a unit vector n. Always unit vector represents a direction. Now, from now on, have this in the back of your mind that a unit vector represents a direction. N cap is a direction. I want to find out the projection of A along n cap. So, we take this dot product n cap dot A, and n cap can be represented as a row vector n x, n y, n z, 3 components, such that n x square plus n y square plus n z square is 1, and a x, a y, a z are the components of the vector A in some coordinate system. We are not right now interested in which coordinate system. Some Cartesian coordinate system we have this representation of these two vectors. We take a dot product, and that can be written as therefore n cap transpose A. And both are actually column vectors or column matrices, columns, and when I take dot product of these two, it is n transpose A. The column vector has been first converted to row vector, and then there is a matrix multiplication. How do you do matrix multiplication? Straightforward, this gets multiplied with this gets multiplied with this, and A z gets multiplied with this, and that is how we, and they are summed up. And dot product is commutative, therefore, n transpose n cap transpose A is A transpose n cap. How do I represent n cap cross A? I write n cap, the column vector n cap column vector is n x, n y, n z, and any such vector can be written in what is known as the Rodrigues form. And you know the note the special structure of Rodrigues form: minus of the first element, second element, negative of the third element, and this is skew symmetric. This matrix is skew symmetric. Therefore, this is the first element, negative of the second element, the third element. Rodrigues form is a skew symmetric matrix representation of a vector which actually represents this n cross. This whole thing is represented by this matrix n cross. And I will represent this n cross as this matrix, n cap matrix. The square bracket will indicate that it is a Rodrigues form of the vector n cap. Now, if I multiply with this matrix with the A matrix or A vector, column vector, I will get n cross A. and remember this is cross product is non commutative. If I want to find out A cross n, then I must write Rodrigues form of vector A and multiply it with n cap. Now, we are going to look at orthogonal decomposition of a vector. What is meant by orthogonal decomposition? Suppose we have a vector A and a direction n cap. We are given a vector A and a direction n cap. I want to find out, I want to decompose this vector A in n cap direction and a direction perpendicular to n cap. I do not know which direction. I do not know what is that representation of that direction. We are going to find out, which means I want to find out two vectors which are mutually orthogonal and which sum up to A. One of those two vectors is along n cap, the other is perpendicular to n cap, and the summation of these two vectors must give me A vector. This is the objective. So, decomposition means that decomposition of vector means finding out component vectors which sum up to the original vector, but here this is orthogonal decomposition in two orthogonal directions. One is n cap given, other direction I do not know, I have to find out. Essentially this we have to find out the A parallel vector which is along n cap, parallel means along n cap, and A perpendicular vector which is perpendicular to n cap. I do not know which direction, but I will find out, and the summation of this A parallel and A perpendicular vectors must be A vector. How do I find out the A parallel vector? Actually this is very simple. A dot n cap gives me the magnitude of, so that gives me this projection, this length. A dot n cap gives me this length, and that is the magnitude of the vector A parallel. You can see from the figure, it is the magnitude of A parallel figure, and A parallel, what is the direction of A parallel? It is along n cap, and any vector can be represented by its magnitude multiplied by the direction of that vector. Magnitude is A dot n cap, direction is n cap, therefore, this must be the vector. A dot n cap will give me a scalar quantity which is the magnitude, and n cap is a vector, unit vector gives the direction, therefore, A parallel is completely known. A perpendicular, how do I find out A perpendicular? Because A parallel and A perpendicular must sum up to A, therefore, A perpendicular must be A minus A parallel. A vector minus A parallel vector will be A perpendicular vector, because A must be the sum of A parallel and A perpendicular. Now, this result we have seen before. From vector algebra we know that n cross A. Now, it is very important now here which cross product is taken first, because if you take the first two cross products, first cross product first, then you will get 0. So, n cross A is n dot A times n cap minus n dot n times A vector. This is a fundamental result from vector algebra, and we have used this before. Therefore, this can be written as A dot n cap times n cap minus A vector, and the left hand side, you recall that every time we can write n cross as the Rodrigues form of n cap, n cross as the Rodrigues form of n cap. Therefore, the left hand side was actually Rodrigues form of n cap times Rodrigues form of n cap times A vector, the column matrix form of A. That was the left hand side. In other words, I can write the left hand side as the square of the Rodrigues form of n cap times A must be equal to the right hand side remains the same. Therefore, this I can write as if I pull out this A from here, what I can do is I can take this to this side, I can take it to the other side, and that I have written on the right hand side, and this I have taken to the left hand side. What do I get? I have pulled out A. After taking that to the left hand side, I have pulled out this A vector, the column matrix corresponding to the A vector. I have pulled that out, and this must be replaced by the identity matrix. This is identity times A vector, sorry, identity times A vector. So, when I pull out A vector, this identity remains identity plus the matrix Rodrigues form matrix n square of that. So, this is the matrix. So, here also it must be a matrix, of course, and therefore, A dot n times n must be equal to I plus the Rodrigues form of n cap whole square, this whole multiplied by the A vector. Now, I am in a position to write down explicitly A parallel and A perpendicular in terms of some matrix multiplied by A. This is representation of the operator. So, these matrices are something like operators, they operate on the A vector, the A column vector. So, the first operator, when it acts on the A vector, gives me A parallel, and when you have this minus n square, this as an operator acting on A, I will get A perpendicular. And how did I get this? How did I get A perpendicular? From here, A perpendicular is A minus A parallel, and what is A parallel? It is this, which is same as this. Therefore, it is I minus Rodrigues form of n whole square times A, and therefore, if I open up the brackets, the A vector will get cancelled. So, I have though this is plus. So, I have minus of n cap whole square times A vector, and that is what I have written here. This is how we finally represent the A parallel and A perpendicular as just some matrix operating on the A vector, and these two matrices are I minus n square Rodrigues form and minus n square, I plus n square Rodrigues form and minus n square Rodrigues form. So, if I have the Rodrigues form of n, I will just square it up, and once I have the square, I can easily find out A parallel and A perpendicular. Next, we discuss a very important theorem known as the Cayley-Hamilton theorem. This says that every square matrix satisfies its characteristic equation. Now, characteristic equation, where does it come? It comes in the eigenvalue problem. Suppose I have this matrix n, Rodrigues form of the vector n, which is matrix n. What is the characteristic equation? I define the eigenvalue problem, lambda I minus the matrix, determinant of that must be 0. If I calculate the characteristic equation of this, that means this determinant, basically if I calculate the determinant of this and I leave it to you, show that this is going to be the determinant of this matrix. Here you have to use the property that nx square plus ny square plus nz square is 1, and using that, and there will be some cancellations, you will finally get this very simple characteristic equation, lambda cube plus lambda is equal to 0. And what Cayley-Hamilton theorem says is that every matrix, every square matrix satisfies its characteristic equation. In other words, I can replace lambda, which is actually a scalar, I can replace lambda by that matrix itself, which means as per the Cayley-Hamilton theorem, Rodrigues form of n whole cube plus Rodrigues form of n must be 0 matrix. It must be 0 matrix. Every element will go to 0. This is a very important theorem. It appears in various places. Okay, so, this is the result from Cayley-Hamilton's theorem. This tells us how, if I keep multiplying the n to itself, how I can simplify. As soon as I reach n cube, I will write it as minus n. That is what it is. N cube is actually minus n, Rodrigues form. Rotation of a vector about an axis. Now, we come to the main problem. All what we discussed was the mathematical preliminary, and we will use all those concepts here to now find out rotation of a vector about an axis, and that will give us, finally we will try to fish out or find out the rotation matrix involved. Just like in the decomposition of the vector A, I finally came down to these operators, these matrices, which actually when multiplied with that vector gives me the A parallel and A perpendicular. Similarly, when I find out rotation of a vector, I can find out the rotation matrix. Now, I am given a vector, a direction and a rotation about that direction. Suppose I rotate the vector A about n cap by an angle theta. What will be the new vector A? What will be the representation of the new vector A? If I know the representation of the new vector A, I will try to relate it to the old vector and find out the rotation matrix. That is our plan. Okay, let us see. I draw a surface which is perpendicular to n. Every direction can define a surface which is perpendicular to it, or looked at in a reverse way, every surface has a unit normal. This is the unit normal of this surface, blue surface, which I have drawn. A will have some projections on the surface and along n, A is not on the surface. If I project A on the surface and on n, that we were doing already, then I get A parallel and A perpendicular. Now, if I rotate about n, the direction n by an angle theta, which vector will rotate? A parallel cannot rotate, A parallel is already along n direction, n cap direction, it will not rotate, it will not change, nothing will happen to A parallel, but what will happen to A perpendicular? It will rotate by an angle theta, that is what it is going to happen. And therefore, we can rotate it A perpendicular by an angle theta and recombine with A parallel and get back what is the representation of A vector in the rotated configuration. Okay. Now, A vector is summation of vector summation of A parallel and A perpendicular, and recall that A parallel is I plus Rodrigues form of n square times A vector, and A perpendicular is minus of Rodrigues form of n whole square times A vector. When I rotate by an angle theta, A perpendicular goes to A perpendicular prime. This is my representation, A perpendicular goes to A perpendicular prime. And what is A perpendicular prime? And when I sum up A perpendicular prime with A parallel, I will get A prime. This is the rotated vector A. I started with the vector A, and now finally after combination I will get A prime, which is the rotated vector A. Then I will try to find out what is the relation between A prime and A, and then get the rotation matrix. Okay. When we rotate A perpendicular and get A perpendicular prime, the magnitude is not going to change. What is going to change is the direction. And how do I represent directions? I consider a perpendicular vector and a vector which is perpendicular to the a perpendicular and n vector, n cap vector. How do I find out something perpendicular to two vectors? I take cross product. I take cross product of n cap and a perpendicular. Then I get this n cap, this green vector n cap cross a perpendicular. And I am going to use directions, unit vector directions along n cap cross a perpendicular and a perpendicular to represent a perpendicular prime. All of these three vectors are in this plane, all of them are in this plane, the blue plane. A perpendicular prime, now what is its representation? Its representation is the magnitude of a perpendicular, which a perpendicular prime's magnitude is same as a perpendicular's magnitude. A perpendicular prime's magnitude is same as a perpendicular's magnitude. Therefore, and I have done the decomposition, therefore, I know this, I know a perpendicular's magnitude. To this I must multiply a unit vector in this direction of a perpendicular prime. How do I find out this unit vector? It is cosine theta, I have marked theta here. Our a perpendicular prime makes an angle theta with a perpendicular. Why? Because the rotation was theta. So, therefore, it must, the angle between a perpendicular and a perpendicular prime must be theta. Now, cos theta is the projection of is a projection of a unit length on a perpendicular unit vector a perpendicular. You see, this is a perpendicular cap. That means, how do I find out a perpendicular cap? A perpendicular vector divided by its magnitude, that will give me a perpendicular cap, the unit vector in that direction. So, cosine theta times unit vector in a perpendicular direction plus sin theta times unit vector in the new direction that I have found, because I can represent a perpendicular prime using the directions a perpendicular cap and unit vector of this whole thing, this unit vector. And how do I find out that unit vector? The vector divided by its magnitude. And this whole thing is a unit vector in this direction. This red unit vector that I have drawn is now this bracketed quantity, and that when multiplied by the magnitude of a perpendicular will give me a perpendicular prime. Now, let us look at these simplifications. I just remove the bracket, a perpendicular magnitude, and here in the denominator a perpendicular magnitude is sitting. Therefore, this becomes cosine theta a perpendicular vector plus sin theta times n perpendicular cross a perpendicular. You see, what is the magnitude of n cap cross a perpendicular? The magnitude of this must be the magnitude of a perpendicular. Why? Because it is the magnitude of n times magnitude of a perpendicular vector, a perpendicular vector times, because it is cross product. So, it is sine of the angle between normal and a perpendicular, which is 90 degree. Magnitude of n is already 1, sin 90 is 1, therefore, its magnitude, this magnitude must be magnitude of a perpendicular. Therefore, from the denominator a perpendicular just cancels off with this. Therefore, we have this simplified representation of a perpendicular prime. I have removed the intermediate steps and finally written out A perpendicular prime, and that is equals to cosine theta times A perpendicular vector plus sin theta times n cap cross A perpendicular. So far so good. Let us proceed. Now, we have to combine. I have A parallel already and I have A perpendicular prime, therefore, A prime will be summation of A parallel and A perpendicular prime. I do that summation, I just have these results. I have A parallel here, I plug in A parallel and I plug in A perpendicular prime, and in order to find out actually A perpendicular prime, I need A perpendicular which are already here, and I do some simplifications. So, here you for example, you will get negative of n square times A, this thing when it goes here, and there is n cap cross A perpendicular vector, n cap cross A perpendicular vector, that turns out to be, because n cap remember is Rodrigues form of n times A perpendicular vector. So, this is equal to this, and when I plug in A perpendicular, so that becomes minus of n cap cube A vector. This is what I have written, and sin theta sits as it is. Do these algebraic steps, you will obtain this, and from Cayley-Hamilton theorem I have n cube as minus n cap Rodrigues form, and that minus minus gets cancelled. So, this must be n cap A vector. Now, with this substitution, then I can write A prime vector as this grand matrix. This is a matrix, of course. I have pulled out that A vector at the end, I have written this. The rest of it must be my rotation matrix corresponding to a rotation about the n cap vector by an angle theta. Since n cap is given, therefore, Rodrigues form of n is known, theta is given, therefore, cosine theta sin theta is known. Therefore, I have the complete representation of this rotation matrix, which is a rotation about n cap axis by an angle theta. Now, you can do some simple tests. For example, you take n cap in the x axis direction, will you get back the rotation matrix about x axis direction which we have discussed? This I leave it to you to check. Please check that by taking successively n cap along n cap as I cap or j cap or k cap, you try to find out the rotation matrix from now this expression. You have to write down the Rodrigues form for I cap, it is very simple, and then figure out or try to calculate the rotation matrix from this is a general, this is a very general representation of the rotation matrix about an arbitrary axis by an angle theta. So, given a vector and a rotation represented by n cap and theta, we have found out the rotation matrix, and inversion of rotation matrix follows the same rules. Transpose is inverse. You can check that the this orthonormality condition is satisfied by the rotation matrix so obtained. You can check by looking at simple examples. So, this is our summary of what we have discussed. We started with some mathematical preliminaries, and finally, we looked at rotation of a vector, and from there rotation of a vector about an axis, from where we derived or we found the most general representation of a rotation matrix when a rotation takes place about an arbitrary direction. So, with that I will close this lecture.